Okay, today we're going to start looking at angles of elevation, angles of depression. So hopefully at the end of this lesson, you're going to be able to solve problems involving angles of elevation and angles of depression. We're also going to get into problems involving road grade. Okay, so an angle of elevation is an angle formed by the horizontal line and then they're looking to the point above. So you can see here, like when you're looking up, that's the angle of elevation. And then when you're looking down, that's the angle of depression. I'm going to abbreviate right there. So you have the line of sight and then the angle formed looking down. Now, one thing I want you to notice that we have parallel lines right here. And then right here, these are alternate interior angles. So no matter what, like how if you were standing up and I was standing down, if I was looking up towards you and you were looking down towards me, like if you were on the top of a building for some reason, how far I look up and how far you look down, those angles would be equal because those are alternate interior angles. So let's start with our first problem. Now, the most important thing in all of these is that you draw a picture. And since we're doing right triangle trig problems, pretty much you're going to always be drawing a triangle. So the main thing is to get your angle in the right spot. So this says the Seattle Space Needle casts a shadow of 67 meters. So we know shadows are going to be in the ground. So right here, I'm going to have 67 meters. The angle of elevation from the tip of the shadow is 70 degrees. How tall is the Space Needle? So you have to think of how tall is going to be. So my choices would be here or here. Now think about how tall you are. You're going to measure your height going straight up. So where I'm going to put my X is going to be right there because that's how I measure how tall. So now I have my right triangle. So now that I have my picture, that was the hardest part. So now I'm just going what I did last week. So I have my angle. This side is my opposite, and this side is my adjacent. So I'm going to say the tangent, because that's my TOA, my opposite over adjacent. So the tangent of 70 is going to be X over 67. Just like with all these problems, it's extremely important that you make them a proportion so you don't solve them wrong. You can see I put X under the tangent of 70. So X is going to equal 67 times the tangent of 70. Okay, so when I put that in, I'm getting 184.08. Okay, it says how tall rounded to the nearest meter. That means the nearest whole number. So my answer is going to be 184 meters. Now, suppose a plane is at an altitude of 3,500 feet. So again, before I go on, I have to think what altitude is. And altitude is how high. So that's going to be 3,500 feet. The angle of elevation, okay, right there, they said that is 29 degrees. They want the horizontal distance. Now, one thing again, you always need to make sure you put your X in the right spot. Horizontal distance is always going to be measuring straight. When you measure, you're going to measure flat. That's a big mistake students make, is they put their X in the wrong spot. Okay, you would measure on the ground right here. You wouldn't measure in the air. Okay, you're not measuring here, you're measuring flat on the ground. Okay, think about if you're measuring something in your house or maybe watching someone in your house measure, maybe you don't. Okay, that tape measure is not in the air. So again, now that I have my triangle, I'm reviewing what happened last week. So opposite and adjacent. Okay, my A is not very good there. So again, we're using tangent. Okay, you're going to find that tangent is kind of common when you're doing these word problems. You won't use it all the time, but it is very common. So now I have the tangent, 29 degrees equals 3,500 over x. Now remember, always make this a proportion. So when you cross multiply, especially for a problem like this, you solve it right. The x doesn't always have to go on the top. So I have x tangent 29 degrees equals 3,500. I'm going to divide both sides by the tangent of 29. Kind of get a little crowded there. So x is going to equal, again, in my calculator, I'm going to take 3,500 divided by the tangent of 29. Okay, I'm rounding this to the nearest foot. My calculator says 6,300, 14,000.16, so I put 6,314 feet. Okay. So for our next problem, we're talking about an ice climber. An ice climber stands on the edge of a crevice. Okay, 115 wide. So he's got this little crevice. It's 115 feet wide. Okay. The angle of depression, looking down. Okay, so he's now looking down in the crevice. So okay, so now we have one with like the angle of depression. So this one's going to be a little bit different. So let's read the whole thing. You've got an ice climber. He stands on the edge of a crevice that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. Okay, how deep is the crevice at this point? So you kind of have to do a little upside down triangle in this case. So right here, this is 115, right? And what I'm looking for is how deep that crevice is going to be at the point. Now, they told you this was 52 degrees. And what they want is how deep it is right there. That's what I'm looking for. Now, one thing you can always do is flip this upside down, because remember, your angle of elevation and your angle of depression are the same. So here's what I'm going for in this case. So I've kind of got this upside down triangle. So again, I have my, let's go with, switch the colors here just so it's a little less confusing. This is my opposite. Oh, I didn't really mean to use that color. Let's switch that back. Opposite, here's my adjacent. So again, I'm going to use tangent of 52 is going to be x over 115. This should say opposite right here. Make this proportion. So x is going to equal 115 times the tangent of 52. Put that in your calculator. Again, we're rounding this to the nearest foot. When you do that, you're going to get about 147. Now here's one where we're finding an angle. Okay, Mrs. Harrington, 67 inches tall. Okay, so if they gave this to you in feet and inches, you'd want to change this to the same unit. So here I am. I am 57 inches tall. My shadow is 80 inches. Okay, if you didn't know, your shadow changes at different times of the day, depending on how high the sun is. I want to know the angle of elevation of the sun. So I'm finding the angle at this point. So opposite over adjacent. That's also tangent. So 57 over 80. Now, remember when you're finding angles, you need to do inverses on your calculator. So tangent -1, cosine -1, sine -1. You need to hit that second key. So x is going to equal tan -1, 57 divided by 80. Okay, so I got 35.4, so at that time of day, it's about 35 degrees. Now we're going to talk about road grade. If you ever drive in different parts of the country, there's different parts of Michigan, you see signs that say road grade. Okay, and that's pretty much, it tells you the steepness of the road. And they often express that as a percent. For example, when something has a road grade of 6%, that means it actually raises 6 feet of the road for every 100 feet. Okay, it travels horizontally. So I have an example right here. It says a highway sign warns that a section of the road ahead has a 7% grade. That's actually very high, not normal. Okay, to the nearest degree, what angle does the road grade make? Okay, so that's rise over the run. Okay, so 7 over 100. You really don't have to express it that way because that's still the 7%. So really all you do is take the tangent of that in your calculator, and then that gives you the degree of the road. So the degree of the road is 4%, which you wouldn't seem like a lot, but that's actually a pretty steep road. So pretty much when they give you a road grade, you can change it to a decimal, take the inverse tangent of it, and that gives you the angle of the road. So for this one, we have a very steep road in the mountains. If you've ever driven in the mountains, it's kind of fun. Well, actually, I'm not the one driving. It's fun to ride in the mountains. So road grade 38%. So that means it's 38 over 100. So the tangent of that is 38 over 100, or 0.38, right? So really, to get that angle, I'm just doing the inverse tangent of 0.38. So you're just going to put that in your calculator. So pretty steep road. Measure of angle A, in this case, is 21 degrees. Okay, now the last thing we're going to talk about is, I want you to know that all the problems here we use tangent. Not all problems, not all application problems use tangent to solve. A lot of them do, but not all of them do. So there might be problems where they talk about something like a kite string, a balloon string, or something like that, and there may be a few in your homework where you may have to use sine or cosine. So again, make sure once you get your picture, you look at that, draw your picture, and then still find out, do you have opposite, do you have adjacent, do you have hypotenuse, and use what trig function you have enough information for. Don't just assume it's tangent.